Good evening, everyone. So my topic for presentation today is basics of ECG for perioperative monitoring. I would rather like to share my screen. So first we'll start with the components of the ECG. So the P wave. P wave is the atrial depolarization wave, and the duration is 0.08 to zero point 0.1 second. The QRS complex is due to the ventricular depolarization, and the duration is 0.06 to zero point 0.1 second. The T wave represents the ventricular repolarization, duration of which is 0.1 to zero point 0.2 seconds. The PR interval starts from the start of the P wave to the start of the QRS, and the duration is 0.12 to zero point 0.2 seconds. The QT starts from the start of the Q to the end of the T, duration 0.4 to 0.44 seconds. The RR interval is the interval between the two consecutive RR of the QRS complexes, and the duration is 0.6 to 0.2 seconds. The J point is the junction of the QRS complex segment, and the ST segment starts at the J point and ends at the start of the T wave. Therefore, it is a junction of the ventricular depolarization and the ventricular repolarization. So this shows a normal ECG with PQRS T waves. Here we can see the small square, and you have to know that the length of the small square is 1 millimeter and the duration is 0.04 second. And large square, the width of which comprises of 5 small squares, the duration will be 0.04 into 5, that is 0.2 seconds. So this is a magnified view of the PQRST. This is the PR interval. This is the J point, so it's a junction of the QRS and the ST segment. And the ST segment starts at the J point and ends at the start of the T wave. These are the PR intervals, RR intervals, and the QT intervals is already discussed. And now we're coming to the conduction of the cardiac conduction. It starts at the SA node, and after activating both the atria, it comes to the AV node, from where the bundle of phase arises, and then it divides into the right and the left bundles, and then through the Purkinje fibers, it activates the ventricular myocardium. So the PR interval actually represents the time between the depolarization of the atria to the depolarization of the ventricle. This whole time represents the PR interval. So how do we go about with the ECG? How do we read it? So the first step is to see the rhythm, then the rate, then the conduction, then identifying the heart axis, and then the morphologies of the P wave, the QRS complex, and the ST segments. And if you have a previous ECG, you can compare the current ECG with the previous one, and then you conclude the ECG. So how do we find the rhythm? First, you have to know whether it's a sinus rhythm. For that, every QRS has to be preceded by a normal P wave, and the rhythm should be regular when the RR intervals are equal. So once you have confirmed the rhythm, you then go to the rate. You have to count the number of the large squares between the RR interval, and then 300 is divided by the number of large squares between the RR interval to find out the rate. The conduction is interpreted by the durations of the PR, the QRS, and the QT. The axis, the normal axis of the heart, is from the -30 to +90 degrees, and you calculate it by taking into account 2 perpendicular leads. One is the lead 1 and other is the lead AVF. The lead 1 is from 0 to 180 degree, and the AVF is from 90 to -90 degree. Now, what you need to see is that which way the predominant deflection on the ECG is, whether it is positive or whether it is negative. If the predominant deflection is positive on lead 1, also it is positive on lead AVF, that means the resulting vector will be in this quadrant, and therefore it will be a normal axis.